Welcome to this video number 13, the exercise 6.21 on second order filters and the solution. Exercise 6.21. Suppose that we want a filter that passes components between the lower frequency of 45 kilohertz and the higher frequency of 55 kilohertz. Higher and lower frequencies are to be rejected. Design a circuit using 1 millihenry inductance. In principle, the filter graph should look like this. The lower frequency should be 45 kilohertz and the higher frequency should be 55 kilohertz. After this slide, the solution will be shown. Stop or pause the video. Try to solve the exercise yourself first before you see the solution. So we need a bandpass filter where we have the lower frequency of 45 kilohertz and the higher frequency of 55 kilohertz. We can calculate the resonance frequency as the sum of the lower and the higher and divide it by 2. So in this case, the resonance frequency is 50 kilohertz. The bandwidth is the difference between these two frequencies. So 55 kilohertz minus 45 is 10 kilohertz. The quality factor for the filter we can find from the resonance frequency divided by the bandwidth. And since we have both, the resonance frequency is 50 kilohertz and the bandwidth is 10 kilohertz. 50 kilohertz divided by 10 kilohertz gives 5. Then, based on the quality factor, the equation for the quality factor, we can now solve for the other two components in this second order filter. We use the equation for the quality factor C resonance, where the resistor is compared to the inductor impedance NQ. So we solve for the resistance and we plot in the data. We have the resonance frequency of 50 kilohertz, we have the inductor of 1 millihenry, and we have the quality factor of 5. That gives a resistor of 62.83 ohm. So that's placed here. Then we, from the same equation, could, or from the resonance frequency, we can solve for the capacitor. There's many ways for this value, but here we solve for the resonance frequency and we use the equation for the resonance frequency and solve for the capacitor. So the resonance frequency we had was 50 kilohertz, the inductor was 1 millihenry and 2p, and then we can solve for the capacitor. It's 10.13 nanofarad. So here we have all the information needed. The next step, based on the calculated value, is to simulate it in, for instance, LT-Spice. I have set up the circuit here, and we can see it is a bandpass filter. We can check that the resonance frequency is 50 kilohertz because at the phase shift of 0 we have the resonance frequency, and if we go in and see, we are very close to it. It's 49.99 kilohertz. It could also depend on if I was able to set the cursor at the right spot. I could have enlarged a bit more to set it better, but we are in the range of. That's good. Then we check that the top here in dB, minus 3 dB down, what are the frequencies? We can see that one of the frequencies is 45 and the other is 56. That also depends on that it is not purely minus 3 dB, it's minus 2.898 here, and here is minus 3.07. If I have used a bit more time on placing the cursors properly, I could have perhaps achieved minus 3 dB better, and the frequency would have been fitting a bit more. Yes, thank you for watching video number 13.